We're going to have 2 more sets of notes, and then I think that's just going to be chunked into 2 more bigger videos. So it'll be this one, and then the next one will be the last one for the last notes. And then you'll have enough information to tackle numbers 23 all the way to numbers 28. Okay, let's go ahead and start doing number 21 because it's a little bit more, I guess, bigger. You know, just a little bit more, so it's more intimidating than number 2. Okay, let's go ahead and do that. I'm going to go and do a couple pre-steps. Then that way it can simplify our graphing and our other steps in finding the other things that we need to find, which is the vertical, horizontal asymptotes. So all that's still going to stay put. But what I mean by this is I'm going to put a pre-step over here, and I'm going to write it kind of small so that I have some space. So let me just zoom in. So our pre-step, let's go ahead and factor already. I know we didn't do that on the first round, but I think it's going to help us, especially when we have like polynomials on the top and bottom. Let's see if we can simplify that just a little bit even more. So that's really the whole purpose of this pre-step. So on the top, I think we can factor out an x. Okay, so now we're left with x squared minus 5x plus 4. How about on the bottom, though? I think on the denominator, we can factor out a negative 4. Okay, so we can factor out a negative 4x, negative 4x. And then we're left with x minus 4. Okay, I think the top is factorable, and it should be. I think the factored form is x minus 1 and x minus 4. Yeah, that's the only way that we can get negative 5 over here. And then on the bottom, we've already factored it to its fullest extent. Okay. All right, and then I'm going to write over here factored form. Factored form. Sorry, it's by the equal sign, but so let me just kind of use a box over here. And then naturally from your Algebra 1, Algebra 2 courses, you would cross off factors that are the same on the numerator and denominator. But let's keep this one because we might use this form in a little bit, and then we'll use the reduced forms also as well. So let's go ahead and reduce that. Bam, bam, and then also these x's are gone as well. Then we are left with x minus 1 over negative 4. Yes. And then this is equal to negative 1/4. I'm just bringing the negative 4 division over as a fraction, negative 1/4 times. And then afterwards, I'm going to distribute. This is negative 1/4 x plus 1/4. Okay. And then I'm going to call this our reduced form. So take a look at what we're graphing really. So what we're graphing really is a line. We're really just graphing this whole thing, this representation of this function is just a line. Sometimes I think that's a little bit funny. I don't know. I know some of you guys don't think so, but it's okay. Like all this crazy stuff, why can't they just say this instead? You know, negative 1/4 x plus 4. I mean, there is a reason why. There is a difference between this and this, and then we'll get into that actually. Okay, so we are going to be graphing this, and I think what we can do right now is let's go ahead and should we just graph it now? I think maybe we can graph it now. Let's go check that out. I need to grab a pencil, so hold on for a second. Okay, let's go ahead and do it. I mean, like the graph is not as big as I want it to be. Our y-intercept is at 1/4. Gosh, this is going to be painful. Let's just approximate that. And then our slope is 1 down, 4 to the right. So 1 down, 1, 2, 3, 4. 1 down, 1, 2, 3, 4. We're kind of almost done, but I'm still going to go over the steps of your vertical, horizontal asymptote so that you guys can see what happens if you have a line, you know. And then there are other cases where if it's not a line, then we really got to do the vertical and horizontal asymptotes. We're still going to do it right now. Okay, there's a reason why I drew it in pencil, because we're going to be erasing a couple things. Okay, so that's going to be our pre-step over here. And the reason why we did that is so that we can see the reduced form, what we're actually really graphing, and then we can see some other forms that will help us along the way. Let's go ahead and start with our first step, just like on the first part of the video, where we're going to find the vertical asymptotes. For the vertical asymptotes, you're going to look at the factored form. We're going to set, and again, the same steps applies. We're going to set the denominator equal to 0. So let's take a look at the factor form, which is over here. Okay, so we have negative 4x is equal to 0, and we have x minus 4 is equal to 0. So x is equal to 0 and x is equal to 4. Do not box them, because I'm going to put a small note over here. Because when we went from factor form to reduced form, they were reduced. They were crossed out. Okay, so if factors are crossed out, they are what's called wholes. Okay. And I'm actually going to put some vocabulary right now for calculus vocabulary. There's a discontinuity at x equals 0 and x equals 4. Okay. Discontinuity at x equals 0 and x equals 4. Discontinuity meaning that there's a hole. What I mean by hole is it's not going to be here. Let's just go ahead and actually do it. It's kind of very similar when we have the less than or equal to sign and there's no equal to sign and you got to make like a circle, a hole. So let's go ahead and do that. So at x equals to 0 and x equals to 4, so there's a reason why I did this in pencil. We're just going to make a hole over here. So now it's discontinuous at x equals 0. And we're also going to make a hole at x equals 4. And it's discontinuous. There's a discontinuity, or it's discontinuous at x equals 4. So we got two holes like that. Okay. So we have holes, or discontinuity at x equals 0 and x equals 4. Okay. So there's no vertical asymptote. Okay. So no VAs. But we have holes at x equals 0 and x equals 4 because at the factored form afterwards we cross those factors out. Okay. We're still going to keep going. We might as well just keep going with step number 2 over here just to find the HA. For horizontal asymptotes, I want you guys to look at the original form. Although we have not labeled it, the original form is the original equation that we started off with. So this is your original form here. Okay, so let's go ahead and take a look. And I think this is where I can put a step 3. 1, 2, 3. If the highest degree of the numerator is greater than the highest degree of the denominator by 1, and I'm only going to give you by 1, then you're going to get what's called a slant asymptote. A slant asymptote just means that it's not vertical, it's not horizontal, it's a slant, either increasing or decreasing with a dashed line. Okay, so it could look like that, or it could look like that. Just a slant asymptote like this. Okay. I can write just a little bit more, and I think I want to write it in a separate pen. So say, for example, f of x. Okay. If our function looks like this, and it does, you know, this could be your p of x, and this could be your q of x. Okay, so if we have a rational function, then to get the slant asymptote, you're going to do division. So it's going to be P of x divided by Q of x. And then whatever this value is over here, that's going to be your slant asymptote C of x. And we will get to use this in a little bit, but I think for today, I just want to put that information in because we're not going to be using it too much, but at least the information is here right now. We're going to use it a little bit later when we go into Unit 1 for limits. Okay, so I'm going to write a small information over here for today. If the reduced form is a line, and actually I don't even need to write for today. Maybe I'll just put like over here. That'll be next time. If the reduced form is a line, there's no slant. There's no slant asymptote. Okay. So let's go ahead and take a look. You know, we have a lot of information over here. We technically could go x cubed minus 5x squared plus 4x divided by negative 4x squared plus 16x. And we can use long division. We will review that in a little bit, long division for polynomials. But we're not going to be needing this today. Okay. The degree in the numerator is higher than the highest degree of the denominator by 1, but because our reduced form is a line, we're not going to have a slant asymptote. We have a line already. Okay, so for this specific example, there's no slant, and there's also no horizontal asymptote as well, because it didn't qualify us to get. And why it didn't qualify for us to get those is because we also don't have these. You know, the highest degree is not equal to, and the highest degree in the numerator is not less than. It was actually greater than, but because we already have a line as a reduced form, we're not going to have a slant. So we don't have a slant nor a horizontal asymptote in this specific example. We are almost done. Now we can do step 3, which is our x-intercept. Okay. I don't know why I put use or the at use reduced form. Okay, our reduced form is f of x is equal to negative 1/4 x plus 1/4. We're going to set f of x equal to 0. We're going to minus 1/4 on both sides, and then divide both sides by negative 1/4. So x should equal to 1. Okay, so your x-intercept is going to be at 1, 0. Okay, well, my graph is a little bit crooked already, because if you take a look, you know, I mean, the way that I drew, just because these were approximations already. So let's just kind of like put that in right there, you know, like that. Okay. So my graphs are a little crooked already. Last but not least, and then you'll get into the last video, your y-intercept. Also use your reduced form, because it's just going to be a little bit easier to plug in your x value. Okay, so f of 0 is equal to negative 1/4 times 0 plus 1/4. This is 0 plus 1/4, so f of 0 is equal to 1/4. But we're going to cross this out. Why are we crossing out the y-intercept? Because we have already established that there is a hole at x equals 0, which is pretty much your y-intercept. Okay, there's already a hole. There's a discontinuity at x equals 0, so no y-intercept because there's a discontinuity there. I know it's such a big word, but the synonym for that for you guys is hole. That's all there is to it. All this information just to draw a line with two holes. Oh boy. You know, sometimes it is what it is, but I think we'll get into a more difficult one on the last video. Okay, so I'll see you guys there.